Alright, so in this video we're going to be looking at breaking down a square root or a cube root or even a fourth root, so breaking down a radical. But now we're going to have variables inside of that radical, which I've only drawn this here to make an example in a second. But first, I've already uploaded another video about breaking down square roots with just numbers, so if you want to go check that out, that would be a good idea. Also, if this video helps you, you can like, subscribe, whatever you need to do. Alright, so let's start off with this. So what I've drawn for you here is a square root, and then we have a inside of that square root. Now, whatever's inside of a square root, we call that a radicand. All right, and then this symbol, a lot of people call it a square root, but it's actually called a radical symbol. All right, now there's one part that I didn't draw or didn't write yet, and that's the most important part that we're going to use for this video, which is there's a little number right here that actually is called, we'll just use n for that, and it's actually called the index. All right, now the index tells you what type of radical you have. Like if we just have a square root, like let's say the square root of 4, technically there's an index here that is 2, which makes this a square root. All right, now if we change this and we make a square root, but we put a little 3 here, and let's say we're doing the cube root of 8. This little cube root, or this 3 here for the index, tells us that we have a cube root. All right, and then the last one would obviously be, well, it's not the last one, but we could keep going. I won't do it, but we could go to 4, 5, 6. We could do as much as we wanted to do. All right, now we'll talk about more about that in a second, but the main part is the number that is, I just always refer to it as like the little number with the radical. If the number's not there, it's a square root and the index is 2. If the number is there, it's a cube root, or it could be a fourth root, fifth root, whatever it is, or whatever the number tells you. So let's use that to first break down a square root. So let's start with a few square root problems. So now once again, I've already put out a video where I broke down just a number like the square root of 32. But now we're going to add this into it. We're going to add x to the 4th and y to the 9th. So all that's underneath our square root. Now, once again, the reason this is a square root is because there's no index written. When there's no index written, it actually means the index is 2. So right now we know the index is 2. Now you're probably thinking, why does that matter? And it's going to matter when we look at these variables. All right, so let's do this. A square root, you want to make sure that when you have variables and exponents, you want to make sure that your exponents are divisible by 2. So divide by 2, or I guess I should say divisible. Let's just say exponents divisible, and I might misspell it. If I do, who cares? Divisible by 2. All right, now here's how we came up with that, or here's an easy way to remember it. Whatever the index is, that's what you want your exponents to be divisible by. Because when we break down this 32, there's really nothing that we need to do here other than break it down like we've done in the past and like I did in a past video. But when we break down x and y, since they have exponents, we need these exponents to be divisible by 2. And for that, I'll show you y in a second. So let's see if we have that. Let's get rid of all this and let's just see if we have that. Now, what I would do as you start to break down this problem, the first thing I would do is I would split this up into the square root of 32 and then break it up into the square root of x to the 4th. You could even break this up again into y to the 9th. Because as long as we remember that all the square roots are being multiplied, it makes it easier for us if we just split it all up. It makes it a lot easier for you to try to read what you're doing. So now, breaking down the square root of 32, we'll do the variables in a second, but let's just handle this part first because hopefully this is the easiest part for you. Now, we can break down the square root of 32 by using the square root of 16 times the square root of 2, because 16 is the biggest number that's a perfect square that divides 32. So then that allows us to say the square root of 4, or square root of 16 is 4, and then the square root of 2 is left over. So that is the number portion broken down. All right, so 4 square root 2 is what we have left with just the numbers. So that part, once again, should be review. If it's not, go back to the previous video that I put up and I would take a look at that. So now, the square root of x to the 4th. Now, here's where this exponent or index 2 comes into play. The first thing you want to do is use that index 2 and say, okay, I want my exponent to be divisible by 2, because here's how you do the square root of x to the 4th. You use that index 2 and you actually divide your exponent by 2. So x to the 4th, the square root of that is going to be x to the 4 divided by 2, which is 2. So x to the 2nd power is the square root of x to the 4th. All right, so now here's what we have. We have 4 radical 2, x to the 2nd. Now we just need to do y to the 9th. But if you notice, 9 is not divisible by this index 2. So an easy way we can do this is we can just use what we know about our exponent rules, and we can break down y to the 9th. We can change y to the 9th into y to the 8th, because 8 is divisible by 2. But now we have to get back to y to the 9th, because we can't just make this y to the 8th and get rid of y to the 9th. But what we can do is essentially make y to the 1st times y to the 8th, because if you remember, our exponent rules say if we were to multiply these two y's, it means we would add 8 and 1 and get back y to the 9th. So we could rewrite this as y to the 8th times y to the 1st power. Because now we're doing the exact same process that we did over here with the numbers, as far as breaking down the square root and taking out some stuff, leaving some stuff in. We're doing that same exact process, but now we're just doing it with letters and exponents, or variables and exponents. So now, let's do this whole process of taking y to the 8th, and we want to do the square root of that. So remember, if you're doing a square root and you have an even exponent that's divisible by 2, you divide that exponent by 2. So y to the 8th, the square root of that would be y to the 4th. Now, we're left with the square root of y. This square root of y is the exact same situation that we had with the square root of 2. When we did the square root of 2, we couldn't break that down any further. It's the exact same situation with y to the 1st, because y to the 1st power can't be broken down any further to try to make an exponent that's divisible by 2. I mean, you could try to get into some like weird logic here, but it's not going to work. So we're just left with y, or the square root of y. So now, putting this all back together, here's what we have. And hopefully you'll get to where you don't have to break it all apart like this, but I'm going to do it just to try to make things helpful. So we had 4 radical 2, we had x to the 2nd, and then we had y to the 4th radical y. All right, so now, when we're putting this all back together, we're just going to multiply everything. So everything that's already on the outside is just going to multiply and stay on the outside. So the outside of our answer is going to be 4x to the 2nd, y to the 4th. That's everything that we took out of a square root. What's left in the square root is going to be the square root of 2 and the square root of y. So inside of our square root, we just have 2 times y, which is 2y. And that would be our answer. All right, so let's look at another one. So once again, the easiest way to try to do this, in my opinion, is to break apart your numbers and your variables. If you can do it all together, then that's good. If you struggle with that, once again, breaking it apart is a good idea. So we have 324, a to the 3rd, b to the 7th. So the question is, what's our index? What type of radical do we have? Is it a square root? Is it a cube root? What is it? So it's a square root. Excuse me. It's a square root because we don't see an index written here, which means the index is actually 2. So now let's break everything apart. So here's our numbers. We'll do the square root of 324. Then we'll do the square root of our variable, which is a to the 3rd, and then our other variable, which is b to the 7th. Once again, if you can write this all together and do it all together, do it like that. I'm just giving an alternate method just so some people that may struggle with this can actually make this easier for themselves. So now let's break down 324. Well, the square root of 324, hopefully we know, or we can use our calculator, is just 18. So that's automatically out of the radical, and then this part is finished. All right, so now let's move on to a to the third. So when we do the square root of a to the third, we are going to first double check what our index is, because remember, if you see an exponent and you're doing the square root or cube root or whatever it is, you need to remind yourself what the index is, because that's what you want your exponent to be divisible by. Like this 3 needs to be divisible by 2, however, we can all see it's not. So what we need to do is break down a to the third so that we can actually make a to the third into an exponent that is divisible by 2. And the easiest way to do that would be to just go down 1. We could go from a to the third to a squared, and now a squared is, this 2, that's our exponent, is divisible by 2. But now we need to break this apart so that we can multiply it back and get a to the third, which just means we need to have another square root of a over here. Once again, it's the same way we break down numbers, except now we're just breaking down variables and exponents. It's the same logic. So now we can do the square root of a to the second, because this exponent 2 is divisible by our index 2, and it would just give us a to the first. But this a, the square root of this a, can't be broken down any further, because if I have a to the first power, there's no way to rewrite that so that it's somehow a to the second power. It's just not going to be doable. Once again, there's a lot of, I guess you could try to come up with a way to do it, but it's just not really going to work, and it's not going to be efficient, so I wouldn't even worry about it. So now, here's what we have on the outside. 18, we have a radical a, and now we're going to break down b to the 7th. So once again, is this exponent 7, is it divisible by 2? No. So that's what we need to do first. We need to break this down so that we make b to the 7th into b to the 6th times b. And then we'll just keep both of those under a square root. All right, so now we can do the square root of b to the 6th, because this b to the 6th, we can just divide that 6 by 2, and that gives us the square root of b to the 6th, which is b to the 3rd. But then this square root of b can't be broken down any further, because once you get below this index, it's very difficult to do it after that. I always just kind of memorize it and say, once this number gets lower than the index, we're done. As far as breaking down what's in the radical. So now, once again, you might be able to put this all together before now, but I'm just going to do it after for those of us that may struggle with this. So I think we said b to the 3rd. Yeah, b to the 3rd, and there's a square root of b left. All right, so now everything that's on the outside is going to get multiplied together. So 18a b to the 3rd. So all that's going to stay on the outside, and then anything that's under a square root is going to get multiplied but stay under a square root. So now we have ab. All right, so I'm going to do maybe 1 or 2 more. I want you to see a cube root, because that's where a lot of this can give people trouble. So let's look at that real fast. Now let's look at the cube root of 216 m to the 3rd n to the 6th. All right, now when we did a square root, we said that n was equal to 2, but now that's going to change because our index, you can clearly see, is a 3. Here's what that tells us. When we have exponents, we want to make sure that our exponents are divisible by, and you could probably figure this out, if when we did an index of 2, we wanted our exponents to be divisible by 2, which I didn't even spell divisible right. Divisible, I think that's right. I hope it's right. Who cares? So if we wanted our exponents to be divisible by 2, now when our index is 3, we want our exponents to be divisible by 3. All right, so we're going to do the exact same process, but now this 3 is going to dictate how we break down our exponents. All right, now when we're breaking down a cube root with a number, we actually break it down the exact same way that we do a square root, except now we're using perfect cubes to help break our cube root down. So once again, I'm going to split this up. If you don't need to split it up, then don't split it up. If you need to split it up, here you go. All right, so I'm going to split all this up into 3 different problems. So the first thing we need to do is the cube root of 216. You can use your calculator, or maybe you have this memorized, but the cube root of 216 would be, I believe it's 8. Let me double check just to be sure. No, it's not 8. I believe it's 6. Yeah, it is 6. All right, cool. So the cube root of 216 is 6. So that part's already done, or we've already done it. That 6 is going to be outside of a square root. So now let's go over here to the cube root of m to the third. Now, when we were doing a square root, we wanted this 3 to be divisible by 2. But now we want 3 to be divisible by 3. So is this 3 divisible by 3? Yeah, which means all we have to do the cube root of m to the third is take that 3 and divide it by 3. And that's going to tell us m is to the first power. So the cube root of m to the third is just m. So that comes out of our square root. Now, the last part is the cube root of n to the sixth. N to the sixth, we need to ask ourselves, once again, what's my index? It's 3. And then I need to ask myself, okay, is this exponent 6 divisible by 3? Could I divide 6 by 3? And you could. So if that's the case, then you bring down your variable, divide your exponent 6 by 3, and that tells you the cube root of n to the sixth. It would be n to the second. So now, if we take all this and put it back together, we don't have anything left inside of a radical. So our answer is just 6m n to the second. I'll do another one because that one was a little bit easier. So now let's take a look at, let's do, yeah, this one will be a good one. All right, so let's do one more. Let's look at the cube root of 56. Let's do r to the 8th and s to the 4th. All right, so now let's start by breaking all this apart. Let's handle our numbers separate from our variables. And once again, if you don't need to do this, don't worry about doing it. I like to do it because it helps with the process. So now, in a previous video, I showed how to break down square roots. Now, I'm going to look at showing you real quick how to break down a cube root when it's an actual number, because we have 56. Now, our job is to simply apply the same methods we've learned with square roots, but now just use cube roots. Basically what that means is this. I want to break this 56 down into 2 numbers that are being multiplied. Okay, and we're going to keep those under a cube root. Now, I want one of those numbers to be the biggest perfect cube that divides 56. And hopefully, if you know anything about cubes, this is pretty easy. We would use 8. 8 divides 56, and then 8 times 7 would give me 56. So the part that I'm actually going to be able to do the cube root of would be the cube root of 8. The part that I can't do the cube root of would be the cube root of 7, so that's the part that's going to stay in the cube root, or underneath the radical. So now the cube root of 8 would be 2, so 2 cube root 7 would be what happens, or what we get when we break down the cube root of 56. All right, so now let's do the cube root of r to the 8th. So once again, what do we need 8 to be divisible by here if we want to do the cube root of r? Well, 8 would have to be divisible by 3, and if you try that, obviously it's not divisible by 3. So our job is to try to make 8 into a number that is divisible by 3. So we want to break it down. And I mean, a good rule of thumb here is you're always going to go smaller than 8. You're always going to decrease this number 8 to get to the number you need it to be. You're never going to go bigger, because like some people would say, well, I can do r to the 9th. But that's not really how we're going to do this. It's going to make our life more difficult. So what could we do here? So we could do r to the 7th, but r to the 7th 7 is still not divisible by 3, so let's try r to the 6th. Is 6 divisible by 3? Yes. So now our job is to just figure out, okay, what has to be in the second radical in order to get back to r to the 8th? And I think we could all figure it out by now. It's going to be r to the 2nd. All right? Because if we multiply r to the 6th times r to the 2nd, we get r to the 8th. Now, we can do the cube root of r to the 6th because all we have to do is multiply, or actually divide, the 6 by 3, and it would give us r to the 2nd. But notice, r to the 2nd can't be broken down any further with this cube root of 3 because there's no way to take r to the 2nd and decrease its exponent to get to 3. It's not going to work. So this is the part that's going to be left over. All right, so now let's do the last step, which would be breaking down s to the 4th. S to the 4th, excuse me, s to the 4th. Obviously, 4 is not divisible by 3, but we could change s to the 3rd, well, s to the 4th to s to the 3rd, and then multiply that by the cube root of s. Because if we multiply it all back, s to the 3rd times s would give me s to the 4th. So now, s to the 3rd, that 3 is divisible by 3, so the exponent would end up being 1 for the answer, so it would be s to the 1st, and then it would be the cube root of s left in the inside. So once again, let me rewrite all this just so you can see, and we'll put it back together, and then we'll be finished. So we have, what did we have actually? We had 2 cube root 7 times, let's see, we had r squared, cube root r squared, times, let's see, I think it was s to, oh no, it was just s, cube root s. All right, so now when we're putting this all back together, we are going to take everything that's on the outside of our radicals, and we're going to multiply those and keep them on the outside. So 2r to the 2nd s is going to be on the outside of our answer. On the inside of our answer, we're going to multiply everything that's under our cube root, but keep it under the cube root. So it would be 7, r to the 2nd, and s. All right, now, you can apply this same process to a 4th root, a 5th root, whatever you need to apply it to. For this video, just to keep it as short as possible, I'm just going to do square roots and cube roots, but there's a quick version of how to break down a radical whenever you have variables. Just remember this, when you're trying to break down variables, okay, so if you have variables, this will kind of put this all in a nutshell. If you have a square root, you want to make sure that your exponents are divisible by 2. All right. If you have a cube root, you want to make sure that your exponents are divisible by 3. All right. Once again, the best way to memorize that would be to memorize what this number is here and here, which is called the index. So the index will almost tell you everything you need to know.